We are going to look at empirical and molecular formulas, and I'm going to bring up a screen. It's been a little bit, so bear with me. And okay, I think we're pretty good. By the way, honors chem students, you will have this in Schoology in the notes and examples, kind of the partial key or notes and partial key. This sheet will be included. So I've kind of updated that to include this sheet. So that's where you can find the notes from here. And it corresponds to page 9 and 10 in your homework packet. All right, so we got empirical and molecular formulas. I think I am sharing my screen. I'm just gonna get a little marker here. That's gonna help me with stuff. And so we got empirical formula. That is the simplest whole number ratio in which atoms combine in a molecule. A molecular formula is the actual whole number ratio in which atoms combine in a molecule. Remember when we say like H2O, it's not measured in grams, it's 2 atoms of hydrogen to 1 atom of oxygen. Well, the molecular formula for water is H2O. It's also the simplest whole number ratio. So a lot of times the empirical formula and molecular formula is the same thing. H2O2 is hydrogen peroxide, so it's actually H2O2, but the empirical formula is, if I break it down, divide each side by 2, it is HO. Okay, methane is CH4. That's the actual formula. The simplest formula would be CH4. This would be butene, it's C4H8. If I divide everything by 4, the simplest formula is CH2. C6H12O6 is glucose, but the simple formula is divide everything by 6, it's CH2NO. This one, divide everything by 2 to get here. And this one, let's see if I can find that molecule, is pyridichlorobenzene, which is this molecule we did in lab. And there's 6 carbons, which are black, 4 oxygens, which are white, and 2 green chlorines. Okay, the simplest formula would be, if I divide everything by 2, would be C3H2Cl. Well, I know more about the molecule if I get a molecular formula, but empirical formula is a stepping stone to getting the molecular formula. Sometimes you know the mole ratios of things, but that's all you have. And then you have an empirical formula, then it leads you to getting the molecular formula. Sometimes you have a gram ratio, but if you have a gram ratio, you can convert that to a mole ratio, which gives you the empirical formula. And then you need more information to get to the molecular formula. So that's what we're going to look at now is empirical formulas, taking gram ratios, converting them to mole ratios, and coming up with the simplest ratio between those numbers. All right, so this example says a gas contains 6 grams of carbon and 16 grams of oxygen. So the temptation is, whole numbers, I'm going to divide everything by 2, and I got, 6 divided by 2 is 3 carbons, and 16 divided by 2 would be 8 oxygens. But we have to convert grams to moles, because remember when we have a chemical formula for something, we're not comparing grams, we are comparing moles of things. So here's what I did. I took my grams divided by the molar of carbon, divided by the molar mass of carbon, and I got a nice, easy number of 0.50 moles of carbon. And then I took the 16 grams of oxygen, I divided by the molar mass of oxygen, which was 16, and I had 1 mole of oxygen. Now, you can visually probably look and say, oxygen, the moles of oxygen is twice as big as the moles of carbon. Okay, if you get numbers that aren't as easy to work with, and that will happen at some point, you can always divide through by the smallest number. And if you divide through by the smallest number, the 0.50, the smallest number of moles, I get 1.0 for the carbon, I get 2.0 for the oxygen, and that's why I know it's carbon dioxide. Okay, so I know its simplest formula is CO2. If I had less oxygen here, it probably would be like if this were 6 and 8, instead of 6 and 16, it would probably be carbon monoxide. And I could reason that out, which would be CO. Okay, so ideally, I'd rather know the molecular formula. Okay, so What I do to find the molecular formula, I have to have one other piece of information. I have to have the actual molar mass of the substance. Okay, and the actual molar mass is given as 88. There's a formula that says take the actual molar mass and divide it by the molar mass of the empirical formula. So what I'm going to do is take this, what molar mass of the empirical formula CO2 is 1 times 12, which is 12, 2 times 16 for oxygen, which is 32, and the molar mass of the empirical formula is what, 44. So what I'm going to do is, see if I can remember how to do this. I'll put this in here and take my actual molar mass, which we said was, try that right here. So I have room 88.0, and I'm going to put that over. I'll draw a little line here. I'll get this equaling. Not really good with all these gadgets here. And we said the molar mass of the empirical formula is 44. And this should always come out to be a whole number with rounding close to a whole number. So I get a whole number of 2. Now, I don't know if you can multiply a number by an empirical formula, but what it's telling me is to take the empirical formula and double everything in it. So ultimately, you're going to get a molecule that would be, CO2, I have twice as many as 1 carbon. So that's going to be a 2C2. See how neatly I can do that. And then it would be O4 would be the amount of oxygen. So I'm just taking CO2, I double the carbon, double the oxygen, and that's what I'd end up doing. So just looking at this, I always prefer the molecular formula, but sometimes if I just have gram data, I have an empirical formula and I can work off this. But I know everything is a multiple of this. So if this is the empirical formula, I know the molecular formula is either CO2 or C2O4 or C3O6 or C408. And if I know about structures of things, I can even kind of eliminate some of those possibilities, and it makes it a lot easier to predict things. But if you have the actual molar mass, which can also be determined, then you can figure it out through this way. So what this has is a number of things. And I think your big step is to convert grams to moles, then do your comparison, okay, to figure out your empirical formula. If it's asked for molecular formula, some of them do, then you can follow these steps right here. All right, I'm going to just go over here. And I think you're going to see, like, I think there's 2, 3, I didn't do anything with 5 for posting answers, but number 2, 3, A, 3, B, and 4 are there, so you can show the work, and then you can check back your answers. We'll look at this in class as questions as needed, but I wanted to get you started with that. All right, thanks for watching. Let me know if you have questions. Thank you.